Hi, so we need to go over factoring polynomials. And polynomials, don't be scared of the long word. A polynomial poly means many, and nomial is a numbers group. So a numbers group would be like 2x squared is a numbers group. It's grouped all together, right? Or 5x is a numbers group that's grouped all together. Or even just the number 16 can be its own group if it doesn't have like an x or a y attached to it or anything. So many numbers groups. So if you have 3 or more numbers groups, 3 or more nomials, then you'd have a polynomial. So we need to factor or simplify polynomials. And to do that, I need to show you what FOIL is first, so you know how to check your work. And FOIL is just factoring in reverse, or unfactoring something, putting it back together into its unsimplified form. Now, FOIL is just a mnemonic that stands for first, outer, inner, last. So you might be asking, well, first, outer, inner, last of what? And FOIL is what you do when you have a formula that is made up of those two parentheses, the two sets of parentheses. So if you have something like x plus 4, x minus 3, you would FOIL that to get it back to its original state. So when you have two sets of these parentheses together, and you want to FOIL them, you want to put them back together and find out what the unsimplified version of this is, you go first. So you do the first the first nomials of each set of parentheses. So that would be x times x, and that's x squared. Then you would do and that was first. Now you would do the outer. So outer would be the x out here and the 3 on the outside. So you do the outside ones. So negative 3 times x is negative 3x. Then you would do the inner nomials in the parentheses, so that would be positive 4 and the x. So that would be positive 4x. And then you would do the last of the parentheses, so that would be the positive 4 and the negative 3. So the positive 4 and the negative 3 together makes negative 12. And so if you just rewrite this, you're going to have x squared negative 3x plus 4x is positive 1x minus 12, because you're going to bring this down and you bring this down. So x squared plus x minus 12 is your final result when you're FOILing x plus 4 times x minus 3. So that's FOIL. Now that's how you're going to check your work after you factor something out to make sure that it fits back together the right way. So now we're going to move on to the factoring, and we're going to start with factoring trinomials. And tri just means three, like a tricycle. A tricycle has 3 wheels. So tri just means 3. So 3, and nomials means number groups. So 3 number groups. Now here's a good example, x squared plus 6x plus 5. So we're going to factor this out into 2 sets of parentheses. Now this x squared, the only thing times another thing that's going to end up x squared is x. So we're just going to go ahead and put these x's at the beginning of these parentheses because x times x equals x squared. So we have that already. Now what you need to do is you're going to take this last number here, which is a positive 5, and we're going to find all of the numbers that multiplied together end up with positive 5. So we're going to start out with positive 1 and positive 5. 1 times 5 equals 5. So that's one set of numbers. Also, we could get negative 1 times negative 5 is a positive 5. So that's another set of numbers. And are there any other numbers that multiply by itself going to make up 5? No. So we're done with that. Now we need to find out which set of those numbers is going to equal this positive 6 in the middle. Because we're trying to find out what when the set of numbers is added together, which is going to equal a positive 6. So which set of these numbers is going to equal a positive 6? So 1 plus 5, when you add these together, is going to equal a positive 6. Negative 1 plus negative 5 is going to equal a negative 6. So we know that this is what we want. So this set of numbers is what we're going to use. And we're going to put those in the end of the parentheses up here. So let's try a 1 and a 5. And they're both positive numbers, so I'm going to put a plus right here. So we have x plus 1 times x plus 5. And now we have to check our work. So we're going to FOIL this back out and see if it's going to give us the original problem, x squared plus 6x plus 5. So we have x plus 1 and x plus 5. We're going to go first. X times x is x squared. Outer, x times positive 5 is plus 5x. And then inner, 1 times x is x. And then last, 1 times 5 is 5. And then we're going to add these together since they're like terms and get 6x. Bring that down and bring this down. So x squared plus 6x plus 5, that is the problem that we started with. So this checks out. It's okay. So we know that this parentheses x plus 1 times parentheses x plus 5 is the same thing as this factored out. Okay, so here's another one. We have x squared plus 12x minus 28. So we need to factor these out, so we know we need to make the parentheses. This x squared is going to be divided out into an x here and an x here. So now we need to take this last number here, negative 28, and get that negative in there. Don't mess up and just do regular old 28. You need to get that negative in there. Make sure you don't drop that negative. So negative 28. And we need to come up with numbers that when they multiply together, they end up with negative 28. So we have a negative 1 and 28 times 28 will be negative 28. A positive 1 and a negative 28 will be 28. A negative 2 and a positive 14 will be negative 28. And a positive 2 and a negative 14 will be 28. Now, what else can go into 28? Can 3 go into 28? No. Can 4 go into 28? Yes. So negative 4 times a positive 7 is negative 28, or a positive 4 and a negative 7 multiplied together is also a negative 28. And that's all you can do for the number 28 or the number negative 28. That's all the factors that we can pull out of there. Now we need to pick which one of these, which set of numbers when added together is going to equal a positive 12. That's the middle number. So we need, when added together, is going to equal a positive 12. So negative 1 for the first set, negative 1 plus 28 is 27, so that's not going to work. A positive 1 plus a negative 28 is negative 27, so that's not going to work. A negative 2 plus a positive 14 is going to be 12. So we can stop right there because we know this set, when added together, is going to equal our number, positive 12. Now, what do we do with these two numbers, the negative 2 and the 14? Well, we put them in the parentheses as the last numbers. So negative 2, and don't forget that negative. You got to carry the negatives and positives with you. And a positive 14. So let's FOIL that out and see what happens and see if we got the right answer. Because you should always check your work before turning in the answer, because otherwise you could have made, an error somewhere, and you could have just as easily checked your work and corrected it and gotten it right on your test, as opposed to just turning in this answer without checking your work and getting it wrong if you messed up. So let's FOIL this out. We have an x times an x is x squared. That was first. And then outer, we have an x times a 14 is 14x. And then inner, we have a negative 2 times x is negative 2x. And then the last is a negative 2 times 14 is negative 28. And then these are like terms. They both just have x at the end of it. So 14x minus 2x is 12x. And then you just bring these down. X squared, negative 28. So is this the same formula that you started out with at the beginning? It sure is. So we know we did that right. So we know that parentheses x minus 2 times parentheses x plus 14 is the factored version of the problem that we were given in the first place. Now let's do another one But if you notice right here, we have a number up at the beginning that we can't factor out. We're just stuck with this 2. So we know that when we get these parentheses in, we could do like 2x here and an x here. But see, that's going to mess up the calculations when we FOIL it out. So we're going to do something a little bit different. We're going to add a couple extra steps to this, but it's going to be a lot easier than what it looks like. Now what we do for problems like this is we take this first number 2 and this last number, -3, don't forget the negative in there, and we're going to multiply these together. 2 times -3, and that equals -6. So the -6 is going to be the number that we're going to factor out over here, instead of just that -3 like we did with the simpler problems. So a -6 can be 1 times -6 equals -6, or a -1 times 6 is a -6, or 2 times -3 is -6, or -2 times 3 is a -6. Now, which set of these pairs of numbers is going to equal this -5 right here? Well, that's going to be this first set, 1 plus -6. If you add these together, it's going to equal -5. So we have our 1 and our -6 are the numbers that we're going to use. But we're going to do something just a little bit different before we get into putting everything into parentheses. We're going to bring this -5x, we're going to substitute this with the new numbers we have over here. So instead of -5x, we're going to have a positive 1x and a -6x. So we're going to have that as a substitute for -5x. And if you look, this is all the same. This is going to be the same thing as this. See, positive 1x minus 6x is the same thing as a -5x, which is what we have going on up here. So we're just substituting these numbers for the -5x. And then you pull the rest of this stuff down, so you have 2x squared, and then you pull this substitution down, so plus 1x minus 6x, and then you pull this down, minus 3. Now we have a 4-number four-nomial polynomial to factor out. So I just rewrote this. Here's our original problem up here is 2x squared minus 5x minus 3. And here is our 4-number groups polynomial, 2x squared plus x minus 6x minus 3. Because if you notice, this positive x minus 6x is negative 5x, and that is the same thing as this negative 5x up here. So we just substituted these two numbers in to get a 4-nomial set instead of our original problem up here. So we're going to go into factoring polynomials that have 4 groups. 4 groups of numbers instead of 3. This 2x squared plus x minus 6x minus 3. Now, this is actually a lot easier than it looks like it should be, because all you have to do is draw parentheses around the first set the first two groups of numbers and draw parentheses around the last two groups of numbers. And don't forget to include that negative sign in there when you draw the parentheses. And then we're going to factor these out each individually. So if we factor out 2x squared plus x, what you can pull out of there is an x. You can't pull anything else out, but you can pull an x out. So we're going to put an x outside of the parentheses, and that leaves us with 2x plus 1. And then over here, the negative 6x minus 3, we're going to want to have the final product of this be positive. So we're going to want to pull that negative out. So what else can we pull out of this this set? We can pull the 3 out. So let's pull out a negative 3, and that leaves us with 2x plus 1. Now, if you notice, when we did that, it made these two parentheses the exact same thing. 2x plus 1, 2x plus 1. So we're going to factor these out by turning them into just one set of parentheses where it says 2x plus 1. And that leaves us with this x outside here and this negative 3 outside here. So we just put those in another set of parentheses right next to it. So the final answer is the quantity of x minus 3 times the quantity of 2x plus 1. And that's the final answer. So now we want to FOIL these back out to make sure that they end up as the same thing as what we started with. So first is x times 2x, so that would be 2x squared, and then outer, that would be x times 1, so that would be 1x, and then inner would be the negative 3 times 2x, so that would be minus 6x, and then last would be negative 3 times 1, and that's negative 3. So you have these like terms right here, positive x minus 6x, and that's a negative 5x, and then you just bring this down, negative 3, bring this down, 2x squared. So is this 2x squared minus 5x minus 3 the same thing as what we started with up here? It sure is. So since we FOILed it, we checked our work, we made sure that we had everything in the correct order, and it turned out when we FOILed it back out, we ended up with the problem that we started with. So we know we did a good job.